Consider the following problem. We need to prove that for any sequence A sub I such that all elements of the sequence are greater than 0 and the product of all elements of the sequence equal 1, some of them will be greater or equal than n. We will do the proof using the method of mathematical induction. Okay. So, for this method, we need first to figure out will that condition hold for small n. Let's say let n equal 2. So we will have the sequence of two elements, A1 and A2, such that A1 times A2 equal 1. So, to estimate the sum A1 plus A2, we will express one of these elements as a function of another. Let's say A1 plus, instead of A2, we put 1 plus 1 over A1, sorry, which in turn can be rewritten as A1 squared plus 1 over A1. Okay? And my goal is to prove that this sum is greater or equal than 2. So A1 squared plus 1 over A1 greater or equal than 2. Okay, first let's multiply both sides by A1, and we will end up with A1 squared plus 1 greater or equal than 2, right? Again, it's our hypothesis, 2A1. Right? Rewrite it as A1 squared plus 1 minus 2A1 greater or equal than 0. But the expression in our left-hand side is a full square of A1 minus 1. And by definition, it's always non-negative, right? Therefore, this proof is complete. Now, assume that for any sequence A sub I such that all elements are positive and the product of them equal 1, the sum of the elements greater or equal than n. Okay? And using that as a starting point, we need to prove that for some sequence with n plus 1 elements and the product condition will also hold and the product of these elements is 1, we need to prove that the sum of elements, right, will be greater or equal than n plus 1. If we will succeed, the induction proof will be over. So, let's see how the product looks like. So, product of all elements, I will write in at extended form. So, it will be A1 times A2 times A3 times many elements I will skip. It will be A sub n, right? And times a sub n plus 1, right? And this equal 1. Consider two cases. First, all elements equal 1. When this is true, the proof is elementary, right? Because then the sum of all elements equal n plus 1, right? And the proof is completed. Okay. So it will be only interesting for us to see the case when not all elements are ones, right? There exist elements less than 1 and greater than 1, right? So product will be 1. So without loss of generality, let's sort our sequence such that A1 will be less or equal than A2, which in turn will be less or equal than A3, etc. This will continue. So the greatest element will be A sub n plus 1. Okay. Now, let's make substitution. A sub n prime equal A1 times A sub n plus 1. Okay. Thus, why I did it? Look, I can rewrite the product of all elements as A2 times A3 times A sub n and times A prime sub n, right? Okay. And this will be 1, right? Because I didn't change anything in the product, right? Plus A sub n plus 1. All right. Now let me modify that as follows. I will have A1 plus, and let's put parentheses, A2 plus A3 plus A sub n plus A sub n prime, parenthesis closed, minus A sub n prime, and plus A sub n plus 1. Okay, so what I did, I just added and subtracted this term, right? So actually I added 0, doesn't change. But notice, guys, inside parentheses, what I have? I have n elements, right? N elements. Meaning this sum, it will be greater or equal than n. Okay? So, using this fact, I can write that the sum of all elements of my sequence will be greater or equal than a1 plus n plus a sub n plus 1 minus a sub n prime. Okay. So, let's recall what we know about a1 and a sub n prime. First of all, a1 is less than 1. Why? We have sorted the sequence, right? And we also know that not all elements of the sequence are ones, meaning that there exist elements which are less than 1 and there exist elements which are greater than 1. Okay? So sorting will guarantee that a sub 1 is less than 1, a sub n plus 1 will be greater than 1. And I can write that a sub 1 equal 1 minus epsilon. And a sub n plus 1 equal 1 plus delta, where epsilon and delta some real numbers greater than 0. Okay? So, what is a sub n prime? It is the product of a1 times a sub n plus 1, which in turn can be written as 1 minus epsilon times 1 plus delta. Or, expanding that, I will have 1 minus epsilon plus delta minus epsilon times delta. Alright? So let's plug all that to the formula for, to the inequality for the sum of all terms. So I will have the sum of all terms from 1 to n plus 1, a sub I, greater or equal than what? a1, 1 minus epsilon, right? Plus n, plus, this is a plus 1, right? Plus 1 plus delta, and minus a sub n prime, which I put minus 1 plus epsilon minus delta, and plus epsilon times delta. So a bunch of calculation can be done here. So what I will cancel 1. I will cancel epsilon here and there. I will cancel delta here and there. And what I will be left with? The sum of all elements of my sequence, a sub I, will be greater or equal than n plus 1 plus epsilon delta, or it will be strictly greater than n plus 1. Why strictly greater? Because we just consider the case when not all elements of the sequence are ones. Okay? If the sequence consists only of ones, like 1, 1, 1, 1, then we would have equality, right? Because the sum of ones will be n plus 1. Therefore, the problem is solved by induction. The proof is complete. Thank you.